All right. Good morning, ladies and gentlemen. Welcome to Good Burger, home of the Good Burger. May I take your order? Today's video is a big one. It covers three different sections from our topic. One page in our notes, we're going to be adding and subtracting fractions with unlike denominators, right, with different denominators. And our goal is to be able to solve problems when we're doing that. So, these next couple of slides in your notes, oops, technical difficulties already. There we go. These next couple of slides are not in your notes. It's just a visual of what happens when we're adding fractions with the same denominator, just as a review. So you'll notice here in this problem we are adding 1/8, maybe, there we go, plus 5/8. Okay. The 1 plus the 5, that's where we're doing all the work. Our 8 stays the same. Right? And the reason for that is that we have pizzas here cut into 8 slices. All right, in one of them I ate 1, in the other pizza I had 5. I was hungry that one. Right? When I want to know how much pizza I ate together, I'm not magically going to have pizzas cut out of 16. I'm still talking about pieces that are 1/8 the size of a pizza, right? A pizza cut into 8ths, right? So if this is cheese and this is pepperoni, how much pizza did I eat together? How much cheese and pepperoni did I eat, right? I ate 6 of the slices. Right? But my slices were out of 8. We're out of 8. Okay. And then a reminder from one of our bonus sections, when we are figuring out fractions in simplest form, we're going to divide the top and the bottom by a number that they have in common, right? 6 and 8 are both divisible by 2, which leaves us with 3/4. Subtracting fractions is actually very similar, except we're subtracting instead of adding, right? Also not in the notes, right? But you'll notice here that when I have we're experiencing a lot of technical difficulties this morning. When I have 2/3 and I'm taking away 1/3, right? So I have right, cut into 2/3, okay? And I want to take away 1 of my thirds, right? Notice all of the work is happening in the numerator because my denominator is remaining 3. I'm still going to end up with something that is cut into thirds. It just so happens when I take one of these 2/3 away, what I'm left with is just 1 out of the 3 sections still left over. So 2/3 minus 1/3 is 1/3. Okay. So how does that help us? Right. So we can add and subtract fractions with unlike denominators by using the least common multiple and the lowest common denominator. That was section 7.2. Right? We can make equal fractions that have the same denominator because we can only add and subtract fractions if the pieces are the same size. So we're going to need to make these equal fractions. So here are some visual examples. Right? In this addition problem, I have 2/3. That's these 2 blue sections adding a green section, plus 1/6. You guys should be familiar with pattern blocks. Right? I cannot combine blues and greens into a new shape called blue-greens. That's not a thing, right? A bleen shape, a glue shape, that's not a thing. Right? But what I can do is I can trade these blue shapes in for green shapes. I can trade my thirds in for 6ths so that everything is the same size. In pattern blocks, everything is the same color, and then I can count them up. Right? So if you'll notice here, each of these blue shapes, if I were to kind of cut it in half, right? I can make two of these green ones out of, right? So when I trade in this 2/3, I'm going to get 4/6 back. Okay. The math here that I just did was that I multiplied this by 2/2 so that I would end up with a denominator that is a 1/6, and my numerator becomes 4. Now I can add 4/6, right, and 1/6. 1, 2, sorry, let me get a color you can see. 1, 2, 3, 4, 5. 5 pieces. Each of these pieces is cut into sixths. Each of those pieces is cut into sixths. Right. Subtracting wise, similar, right? I can't take a red shape, a half, and just start taking away sixths. They're not the same size. But you'll notice, right, that I can trade that red shape in, right? I can take my half, I can multiply it in this case by 3/3 because 2 times 3 is 6, and I need to be working with sixths. 1 times 3 is 3. I trade in a half, I get 3/6. Now I can physically take, right, I can physically use this 1/6 and take one of those away, right? I'm taking 1/6 away from my 3/6, and so what I'm left over here with, right, is 2/6. I have these two pieces left over, right? This step right here, this is the new piece in this topic, is making these equivalent fractions, and we're going to talk about how right now. All right, so let's highlight these 4 steps. They are the same whether you are adding or subtracting. All right, so in this particular one, we're going to be working with the fractions 2/3 and 1/4. The first step is to find the least or lowest common multiple. So I list the multiples of 3 and 4. This is where your orange sheet will come in handy. So what do they have in common? Let's see here. 3, 6, 9, 12, 15, 4, 8. Ooh, they have 12 in common. Excuse me. So now, section 7.2 taught us how to make common denominators. I'm going to make 2 new fractions out of 12. So what times 3 is equal to 12? Well, that is 4. So 4 times 2 is 8. What times 4 is 12? Let's see here, 4, 8, 12. Well, that is 3. So 3 times 1 is 3. We're going to add them first. 8/12 plus 3/12. So here my denominator stays 12. Right? Keep the same denominator. 8 plus 3 is 11. So when I add these together, Dana ate 11/12 cups of yogurt. Okay? Let's flip that, right? There's another box under here. Let's subtract them. Again, my denominator stays the same. 8 minus 3 is 5. So 5/12 would be the answer to our subtraction problem. 4 steps, right? Find a common multiple. Make equivalent fractions. Add or subtract, whichever the problem calls for. Simplify if possible. Let's try some. All right. I'm going to do one of each, and then we'll pause the screen, and you guys can try some on your own. All right. So in this first one, right, we've got fifths and sixths. So if we look at the multiples of 5 and 6, right, we can list those out. So we have 5, 10, 15, 20, 25, 30, 35, 40, 6, 12, 18, 24, 30. Oh, look at that. So I'm going to make these into fractions out of 30. I'm also going to erase this just for space sake. That's not erasing. There we go. How did I get from 5 to 30? Well, if I skip count and use my fingers, or if I use my multiplication chart, 5, 10, 15, 20, 25, 30, that will be times 6. So 6 times 4 is 24. How did I get from 6 to 30? 5, 10, 15, excuse me, 6, 12, 18, 24, 30. I started counting by the wrong thing. All right, that's 5 of those. So 5 times 1 is 5. When I add, 30 stays 30. My pizzas are cut into 30 slices. 24 plus 5 is 29. You can check to see if you can simplify. What do 29 and 30 have in common? If you use the back of your orange sheet, you'll notice the only factor they share is 1. That's in simplest form. All right. 3/4 minus 2/5. All right, here we go. 4, 8, 12, 16, 20, 24, 5, 10, 15. Ooh, I like that 20. We're going to make these into fractions out of 20. How did I get from 4 to 20? If you don't erase this, this is helpful, right? 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5 is 20. So I must multiply by 5 up top. 5 times 3 is 15. How did I get from 5 to 20? 5 times 1, 5 times 2, 5 times 3, 5 times 4 is 20. So 4 times 2 is 8. All right. My denominator will remain a 20. 15 minus 8 is 7. The only thing 7 and 20 have in common is 1. We are finished. I want you to pause the screen and try these problems. All right. A lot of stuff going on the screen right now, but the circled answers are your final answers. So if you got 5/9, 5/8, or 1/2 for 2, 3, or 2, then you're in good shape. Okay. So the things I will point out, on each of these you needed to simplify. So a reminder that when you simplify, you are actually going to divide by a factor that the numerator and the denominator have in common. These are both even. Divide by 2 over 2. 5 and 10 are both divisible by 5. 15 and 24 are both divisible by 3. Okay. So, some next steps for you would be to log into the online textbook, choose the practice buddies. You're going to choose 2 of the 3, right? So that's 7, 3, 7, 4, 7, 5. You need to do at least 2 of the 3. Okay? You need to do at least 2 of the 3. I don't care which 2. If you have questions, please come and see me. Have a great day.